Welcome to part 2 of Structural Mechanics 3. In this module, we're going to cover plastic limit analysis, key topics, concepts, and procedures. So what is the aim and objective of plastic limit analysis? The aim is to understand how structure can fail due to plastic yielding of material. In this module, you will learn which between elastic design and plastic design is a more economical design. What is elastic design? Elastic design occurs where no point of structure may exceed the yield limit, i.e. for any point at x of the structure, this should be satisfied. Where maximum stress is the maximum stress in the structure is called the safety factor. Main disadvantage. The resulting design may be excessively safe and not the most economical. Many structures can safely sustain substantial plastic straining before getting anywhere near collapse, i.e. material point failure may not lead to a structure failure. This is particularly due to redundant structures, where the design that allows for safe plastic straining will be generally more economical. So elastic design is where no stress is greater than the yield stress of the material, which lead to a conserved but an economical design. On the other hand, in plastic design, some plastic deformation is allowed. Some plastic deformation is allowed in plastic design, resulting to a more economical design. So the basic idea in plastic design is to allow possible plastic deformation under a given service load without collapse. The ratio given here, beta, which is where P is the applied service load and PC is the load needed to cause plastic collapse, called the load factor. This approach is applicable mainly due to structure made of ductile material, i.e. photo frames. So in equilibrium, this equation is satisfied, and the plastic collapse at load WP, where WP is given by that formula. That is 3A stress in the y direction over L, which should be greater than 5/2 A stress in the y direction over L. Key concept, failure mechanism. Material point failure. Stress at the point, stress should be greater than stress in Y, that is yield stress, determined by the stressed strain curve, assuming perfectly plastic after yielding. The stress across the whole section of a member equals to stress in Y, and the section becomes a plastic hinge. When sufficient plastic hinge appear, the structure becomes a mechanism and cannot take any further load. P, plastic limit should be greater than collapse load. Collapse load depends on the structural and loading condition and requires use of various methods to determine. Plastic hinge Plastic hinge and moment sections for sections. Plastic hinge pH is where the whole section yields. Axial force equilibrium determine the echo area. Moment equilibrium give plastic moment where y with the origin at echo area axis. Neutral axis in symmetric section is equals to echo area axis. In asymmetrical section, neutral axis is not equal to echo area axis. As shown here. So this one is symmetric, this one is asymmetric. You need to know how to compute all these values for any given shape, assuming yield stress is known. So elastic and plastic module and shape factor are given by this formula. Unequal theorem. The true plastic limit, that is P critical, satisfy three conditions. That is equilibrium, the structure is in equilibrium. Yield condition, that is any section where M is less than MP. Mechanism condition, the structure become a mechanism. That is in the unique theorem. Number 2, lower bound theorem. Only equilibrium and yield conditions are satisfied. The load will be equals to P should be less or equal to PC. That is the theoretical foundation of static method. Upper bound theorem. Only the mechanism condition is satisfied. The load will be equals to P is greater than P critical. The theoretical foundation for virtual work method. That is the upper bound theorem. So these theorems of plastic analysis can be shown in this diagram. Static method of plastic analysis. Gradually increase the load until the structure becomes a mechanism. Equilibrium. Used to obtain the bending moment distribution at any different stages. Elastic, plastic, or mechanism. Yield condition introduces a new pH when M is equals to MP. Mechanism condition. The collapse load is found. P is equals to PC when the structure becomes a mechanism. Approach the collapse load from the lower side. Must draw collect bearing moment diagram. Identify and introduce collect pH at right places. Can be used for beams but not suitable for more complex problems such as frame. Difficult to use in general. That is the static method of plastic analysis. No formula to tell how many pH are needed to lead to a mechanism. So those are the advantages and disadvantages and what you need to know about static method analysis. Key procedure, the virtual work method. Virtual work method. The method is based on the fact that when collapsing, the virtual work of plastic hinge must equal the virtual work of external load. The method comprises the following step. Identify possible collapse mechanism. Apply virtual work equation to find the collapse load for each assumed mechanism. Choose the lowest collapse at the actual one, that is P is equals to PC. So here, there's no need to sketch the bearing moment diagram. For a structure subjected to only N point load, the virtual work equation is the presence of M hinge reads, so which is represented in this formula. That is summation of P into the displacement 1 should be equals to summation of Mj into theta j, where P are the applied force, M are the plastic moment at the hinges, and that is that for that shape and theta are the corresponding virtual displacement and rotation. Typical example. Example 1, probe cantilever, degree of interdeterminacy is equals to 1, requires 2 hinges. So you can see this one is fixed at this point and is pinned at this point. So the assumed mechanism is as follows, where here there's some degree of freedom, but here is assumed to be pinned, but it can only move in this direction. So note that for small deflection, the formula is as follows. So should consider all possible mechanisms. So this virtual method is simple to use and you should consider all possible mechanisms. Combination of both static and virtual work method or concept. Replace redundant support with unknown reaction force to make the structure statically determinate. Draw the bending moment using the reactions. Identify the number and location of possible pH to make the structure a mechanism. Use equilibrium equation and pH conditions to determine the corresponding load and reaction. Checks maximum Bm. If M is less or equals to Mp, the collapse load is found. Otherwise, go back to try another mechanism. It is most effective method for most cases. That is combination of static and virtual work methods. Requirement: can use all three methods to solve beam problem. That is statically indeterminate as shown here, continuous beam as shown here, and distributed loading, that is can be equally all. So here for statistically indeterminate and continuous beam, how many pH and location? Unknown pH, location. Photo frames requirement can use two methods, virtual work and mixed, to solve photo frame method. So the first method is not applicable in photo frames. So you can see here an example of independent mechanism, example of combined mechanism, and load combination for two forces. Can use two methods, that is virtual and mixed, to solve photo frames method. Cancelled, you can see example of cancelled pH. Only consider independent mechanism and combine with cancelled pH. Location of pH at the weak points. So in real structure, joints are usually stronger than members connected to them. Thus, plastic hinges form in fact at a small distance from the joint. When two members connected at the joint have different plastic member capacities, the hinge will be obviously form the weaker member. For example, if the two vertical members of the previous example are weaker than the horizontal member, the hinges will form as shown. So beam mechanism, sway, and combined mechanism. So you can see combined, hinge removed, in interdependent examples. Mechanism similar to photo frame. So here you can also use only virtual work and mixed to solve photo gable problems. Import new concept, instantaneous center, geometric relation complicated. So you can see the examples here. Let's go back to following example 1 from this slide. Pay attention to where plastic hinge will be for each mechanism. Beam mechanism is given by the formula. Sway mechanism is given by the formula, this formula. and combined mechanism is given by this formula. So 2 vertical members MP and horizontal member 3 MP. You can use static and mixed method. So label the frame as shown. Assume reaction R at C. Sketch bending moment diagram for each force, that is P and R. As you can see, this is a point load and this one is a R load here. R at 4 meters and P point load at A meters from this fixed end. The 2 pH at A and B is equals to 2.5 meters can be given by this formula. So repeat the above step, but A is unknown now. So PCR is equals to 1.4571 MP. You can use static or mixed method. That is the end of this lecture. If you like this video, please consider to subscribe. I'll see you in my other video. Thanks.